So this is the most important thing here, that is branching. So branching instruction means like whenever we are learning the programming concepts, this branching is very important. So for understanding this, we have, whenever you get an instruction, you have to know what does that instruction means, right? So branch instruction is them that is actually is going to modify the flow of the program. Okay, flow means like there isn't a flow in which the program can execute. I told you, one program executed, then the next program would be that current instruction plus 4. That is the normal flow of our execution. But when branch instruction comes, what happened is that the normal flow of the instructions would be not get executed. Okay, that means branch instruction can modify, that is branch, we know if that, like if you consider if statement, if a is equal to b, if a is equal to b, then I would say x value is 10. So here what happens is that if this condition satisfied, then I have to go to here, otherwise I have to go to else statement. So the instruction which is present in the else statement would be, let's say, another instruction. So if this statement become false, I have to go to this instruction. So the normal flow of the execution is not modified here. Okay. So in RISC-V, you don't have this direct if. You cannot use this direct if statement. So for doing this branching instruction, we have this separate common instructions here. There are this: branch equal to, branch not equal to, branch less than, branch greater than equal to. Okay, so branch equal to means what? Branch equal to means branch if equal. Branch not equal to means branch if not equal. Branch less than means branch if less than. Branch greater than equal to means branch if it is greater than or equal to. Now these are all for the signed. If you have unsigned, then you can write u in it, u at the last. So the operands can become now, so that in that case the operands can be treated as unsigned. Okay, we have different examples for understanding this. So here if you see, I can give different examples. Let's see how you have a code. Let's say if a is equal to b, okay, then c is equal to a plus b. This is the code. I have to write this code in my RISC-V assembly language. How can I do? First let me say that x10, this x10 contains a, x11 has b, and let us say that x12 has c. This is my initialization. So first I have to specify that in which register these values are. So I'm just saying that in x10 there is a, then I said that in x11 there is b, in x12 there is c. So I will check. So I have to check if this a is equal to b, then I have to do this condition, otherwise I should not do anything, right? So I can write it as that. I will write if branch equal to would check if both of them are equal. So I'm going to check which of them are equal. I'm going to check a and b, that is x10 and x11. If x10 and x11 are equal, that is what this means. If x10 and x11 are equal, then I have to go to L1. That is the L1 would be the label where I have to go. Okay, so when I reach the L1, what I'm going to do is that I told you L1 is the label where I have to go. So if L1 means what, it is going to do say c is equal to a plus b. Okay, so that means I am going to add instruction is used. I'm going to add a and b and put the result in c. C is 12. So where I'm going to put the result in x12. What I'm going to add? x10 and x11. Oh sorry, it has gone a little down. 1 minute guys. Okay, so here we got x10 and x11 is added. Now the problem arises here is that what happened if this branch is not correct? Okay, so if the branch is not correct, then what we will write here? So in this between, okay, that means if the branch is not correct, that means here before going to this L1, I have to say that I have to go to int. That means I will write j int. So that means at the end there would be nothing because I'm going to the end. Understood? So that means here what happens is that only if my branch is equal, that is only if x10 and x11 is equal, okay, if I equal, I will go to L1, otherwise it will skip to end. That means here in between here I will write what? J end. So end is empty here. Understood? Okay, let me just write another example. Okay, I will just show you another example here. If A is greater than B, then C is equal to A minus B. I'm using the same register. X10 is A, X11 is B, X12 is C. Okay, I'm using the same register. I would say this is branch is greater than. Okay, if branch is greater than, I can use, I have branch greater than equal to. I can now let me just use with the opposite condition. That means if branch is less than, if I'm using that, it means if A is less than B, if that situation comes, right, if let us say what should be less? B is less, so S11. Let me do the correct condition. S11 x10. That means this would means what? B is less than A. That is what it's written here. So if B is less than A, I have to go to L1. Otherwise, if that condition is not satisfied, then I will go to end. Otherwise, I'm going to jump to end. That is what it means. So if this condition is satisfied, I will go to L1. And in L1, we are doing subtraction instruction. We are going to put the result in C, that is x12, by subtracting x10 and x11. Otherwise, it is end. End has nothing in it. End is basically empty. Okay. Now, this is one example. These are all if examples. Okay. Now, let's see another example. Okay, we are doing some RISC-V examples itself. For all of this, but before that, if you see, if RS1 and RS2 are equal, then I will jump to L1. That is what this means. If RS1 and RS2 are not equal, then I will go to L2. If RS1 is less than RS2, then I will go to L3. That is what this instruction means. If RS1 is greater than and equal to RS2, that is branch greater than equal to is here, then I will jump to L4. That is what each of these instructions means. Okay. Now, let's understand here. J I told you for jumping. That is what we have done. If this condition is not satisfied, then J end means I will jump to end. That is what J means, to jump. Okay. J is used for jump. Now I told you how we are doing if statements. Now let's see how we can do if else statement. Okay. So if statement can also be done in the way by doing the opposite condition. Like that also you can do the if statement. Like if the question is like if A is equal to B, then jump to L1. I can do like this also, or I can say that if a branch not equal to A and B, then I will go to the end. Otherwise, I will do the instruction which is given here. For example, Like opposite condition also you can check. Fine. Now let's see an example for if else. Let's see an example for if else now. Fine. So here if you see, if A is less than B, if A is less than B, then C is equal to A. Otherwise, else C is equal to B. This is my code. To write the RISC-V code, let me say A to B. A I am taking X10, B I am taking S11, the same thing. C I am taking S12. So here what happens is that branch less than X10 and S11, then I go to L1. I will go to L1. Okay. So now what happened is that I'm going to L1. Otherwise, so that means in L1 I will do what I require. That is at C I'm going to add A. So at C if I want to add A, either I can do two ways. Either I can do that, I can add with 0, or I can use like the move thing. That means MV means move. Move X12. In X12 I'm going to add, I'm going to put what X11, that is, sorry, X10. That is what the L1 condition, right? I'm putting this A in C. That means move A to C. That is what this means. Otherwise, if that condition is not satisfied, then I'm going to move what to C? I'm going to move B to C. So if this condition doesn't satisfy, then that means I'm going to move to X12 what? X11. Then J end. That means now I'm going to what? End. It is over. Understood? Now I don't want to do this instruction. I'm going to skip. After doing this, I'm going to skip, because L1 is used only when this condition is there. Understood? So this is we do if else condition. Okay. Now let's do an unique example here. Let's do a different example. That is, if A is greater than B. Okay, if A is greater than B, then I have to execute if A is greater than C. It's like nested case. Okay, then I have to write D is equal to A. If this is the code that I have to do, how we can execute that? So first, let's see. If, that means branch, if this condition is satisfied, then I have to go to this condition, right? So in the branch less than B, let's say B is X11, this is X10, C we know would be S12, so D I can write it to be X13. Fine, this much is done. So branch less than, so our condition is B less than A, let's say. That is, if X11 is less than X10, this is the condition. I'm going to move to L1. So in the L1, what we have? L1 we have another branch. That would do C less than A I have to do, right? So X12 less than X10. If that condition satisfied, I'm going to jump to L2. Fine, I'm going to jump to L2. So I will go to L2. So in the L2, I have to move to the D but A. So I'm going to move to X13. I'm going to move X10. A. Fine. Now if this isn't satisfied, then I have to go to J end. Okay. So when I go to J end, I will directly go to J end. So now when I reach, when this condition is satisfied, reach L1, then I can't, this condition becomes false, means I have to again go to J end. So here also I will write J end, because I don't want to execute L2 now. So finally I will put L end here. Fine. Understood? This much we have understood. This is how we are writing if, else and if loops. Understood? Fine. Now if I wanted to write a particular value into a register, let's see, I want to write in S0, I want to write, let us say, in S0 I want to write 10. That means I can use this instruction, li S0, 10. This instruction means that sometimes in some registers, if you feel like if you want to put some values for doing the for writing the RISC-V code, then you can put that integer. You can, this li means what? Loading the integer. So you can load that integer 10's value to S0. You can do it like that also. Understood? Okay, this is done. Now the next thing that we are going to do is, the next thing that I'm going to talk about is how we are going to deal with loops like while loop and for loop and will come. Then how you can do, how can you write the RISC-V code for that, assembly code for that. So let's see that. So here if you see in our PDF, the conditional statement if, in here what it is doing is that in here the opposite thing it is done. That means, for example, if I am doing this instruction, if apples is equal to orange, f is equal to g plus h apple. So this I want to write it into, let's say, I want to write in RISC-V assembly code. So I can write in different ways. Okay, there are different ways which are possible. First, if I'm writing in my way, I'm going to say that first you can initialize it like this. Like this you can initialize. Initializing means either, since apple and all I can load integer. So I'm going to just say that hashtag that I would say S0, I'm putting in the register S0 apple, in the register S1 I am putting oranges. Like that I can say first. In S2 I am putting F, in S3 I am putting G, in S4 I am putting H. Now if I'm doing this in the way that I teached you, first what I'm going to check is that branch equal to, if apples are equal to oranges. So that means if S0 is equal to S1, then I have to go to L1. So that in the L1, what we are going to do, in the L1 you are basically in the L1 what you're going to do is that this is what you're doing in the L1, and this is outside the if loop. That you have to understand. If this condition is satisfied, you're going to do this, otherwise you're going to do this. Okay, this is outside, this condition is happening outside. So here you can write branch equal to S0 S1 L1. Then you write in the L1 the condition that is f is equal to g plus h. That means adding in f where is S2. So in x2 I'm going to do g plus h, that is S3 and S4 we are done. Okay, so now if this condition doesn't satisfied, then apples is equal to oranges minus h. That is what it means. So apples is equal to oranges minus h means subtraction. Apples is S0, oranges minus h, h is S4. This will do. Now I don't want to execute this L1, then I have to go to end. So j end, I'm going to what? J end. Like this you can do this code. See, you can do this code by using the condition which I told you, like that. Otherwise you can first check that, see, branches is not equal. First we will branch not equal, that is we will check that S0 and S1 is not equal. Then I have to go to L1. So in the L1 you have this not condition. Okay, and if this condition is becoming satisfied, means you're going to do this whatever inside, f is equal to g plus h. So that means opposite condition. Sometimes in here in this PDF, the way it is followed for if or else is that in the branch we will check the opposite condition, and if that condition becomes true, if that opposite condition becomes true, that means we are doing what is not we needed in the if. That is this. if that condition become true, we are doing this because we don't want this. So we are doing the opposite condition. Opposite condition become true means this would occur happen, and if this doesn't happen, then what we needed would be here, f is equal to g plus h. Understood? So in the opposite way also you can do, instead of doing branch equal to, this is how you want to do in branch equal to, that I have already told. This is how you can do in the opposite method. Okay, so here also if you see, if I'm doing this in the opposite method, if this I'm doing in the opposite, I will check if branch not equal to I equal to j. I is x22, j is x23. I will see that they are not equal. If they are not equal, I am going to if they are not equal means I am going to skip, that is I can't do anything, right? If they are equal means would be the necessary, so unnecessary jumps I can avoid, like the j and all I can avoid that if I'm doing in this method. Fine. So if this doesn't satisfy, then we will do f is equal to g plus h, that is g is x20, x21 is h, and that result you're putting in x19, that is f, right? So if this condition becomes false, then this would happen. If this condition becomes true means it's skip, nothing. So that what happens is that unnecessary writing lot of j and condition is not here in this case. That can be resolved here. Okay, so you can use any way, you can use the other way or this way. Okay, then we have already discussed if else statement. So you can also do if else statement like how I told you. You can do it like that. That means if I am doing it in this question in the way that I told you, I will check branch equal to s1 comma s2, then I will go to L1. So in L1 I have what? Add immediate value, because I am adding 1 directly, so add immediate. So to the s0 I am adding s0 and 1 means s0 is added. So here if I want to write 1 2 3 or something like immediate values, then I will use add I. Okay, otherwise what we are going to do is that otherwise we are going to do here is subtraction. Okay, subtraction. You can do a subtraction here, or you can just say adding immediate value also you can do, because I cannot, like I will say adding immediate value itself, in s0 minus 1 I will do. Fine. Else part, then no, we should not execute this L1, so that is why I'm going to end. Fine, like this we can do, or you can do as s1 and s2. If it is not equal, then I have to go to the else part. So in the else part you have whatever you require in the else part. Fine. Then otherwise we are going to do this. Okay, we are going to do this, and we don't want to execute this else part. Then we are going to do the end, that is j end. This is the same thing, j end. If means instead of j end it's like end if, but both works the same. We're going to skip the else part. We don't want this to happen, that is why we are going to the end if, but both works the same way. So you can use this method. If you have learned this method more better, you can use this method. Okay, it's kind of same, just the opposite condition is checked, that itself. So I want you to try to do this. I want you to try to do this particular part. The answer is still there, but try to do it by yourself. Fine. Now this is the case where we are doing if and else. Now if you have to do switch case, that is switch or case, switch case, how we are going to do? So in order to do the switch, that is switch and case, you are having switch button. According to the button, if my button's value becomes 1, then I have to do the case 1. Otherwise I have to do the case 2, case 3 like that, and default value. So this can be done how? The switch case, how we are going to do? Let's see. So first understand the questions. I will give you some time so that you can understand this question here. Fine. So I would say that the button is S0. Let me say the button is S0. Fine. And my AMT value is S1. So it will check if my case 1 means what, if my let's say first I'm going to load integer t0 I'm going to place. So in that t0 I'm putting 1. That means if my t0 is equal to this s0, then I have to change the value of m2 am2. That means I'm going to go to case 1 if it is that case. If my s0 and t0's value is 2 means I have to go to case 2. Otherwise I have to go to case 3. So how we are going to do this, I will just show you. Wait a minute, I want a blank page for that. So I'll write it here. I will write the code here what we are going to do in this case whenever switch comes. Okay, so switch means what, you're going to here there is a switch case. So the code was like this, there is a switch case. First let me just write the code. Switch button, switch button. 1 minute guys. Okay, switch button, fine. Now there is more cases, like case 1 is the case 1 comes means amt's value becomes 20 and I'm going to break. This is what case 1 means. Now if case 2 comes, amt's value is going to be 50 and break. 50 and break, fine. Now case 3 comes means what, my amt's value is going to be 100 and break. Otherwise there is default condition, amt is equal to 0. This is the code. So for this code we are going to write, so let's say my s0 to be button. Okay, so this is just my initialization, s0 to be button. Whatever be the button's value in there, that we are going to take. So if I want, I can load any integer to s0, let's say 2. That means whenever case 2 comes, that's what I have to go and check that. So now I'm going to first say that this is s0 saved. That is, it's always the saved part. Now amt value I don't know, so what I'm going to do is that I'm going to in the amt, let me say that amt is s1. This is amt. So that in amt, let's say I'm going to load the integer 0, because right now I'm not doing anything, I am having integer 0 in amt, fine. Now I have a temporary register. I'm going to load into this temporary register 1. That means if it is 1, I'm going to check branch equal to, I'm going to check if this t0 1 means case 1 I'm talking about, and the button s0 is same. So if s0 and t0 are same, then I'm going to go to case 1. Understood? Because I have loaded t0 to be 1. T means what? It's temporary register, so the value can change. Okay, so that means again now I can load in t0 2, and if I'm checking the branch again with s0 and t0, I can go to case 2, because here what happened, my button's value, if it is equal to t0, then I will go to case 2. Now again I'm going to change the temporary values to be 3. Okay, that means branch is equal to s0 and t0, then I will go to case 3. Otherwise I'm going to end, that is why I'm writing j end. Okay, end means I'm doing the default thing. Okay, that is nothing, because default I put the t0, sorry, s1's value to be amt is s1, right? Fine, this much we have understood. Now what I want to ask you is that this much we have, now we are writing the code for case 1, case 2. So if it is case 1, okay, I'm going to remove this. If it is case 1 means what? Case 1 means, I told you, in the amt, that is my s1, I'm going to write 20. Okay, so case 1 means what? I'm going to load integer to s1 20, and I'm going to go jn, because I don't want to execute the next case. That is why break we are doing. Okay, if it is case 2, then I am going to load to this amt 50, and I am going to do the j end. Understood? And if it is case 3, Then I'm going to load integer s1, I'm going to put 100, and I'm going to do j end. Fine, finally end. This is how we are going to do. So first thing is what we will check. If my we have created t0, the temporary, that t0, first I put the value 1, I load 1 to it. So if I load 1 to it, I will compare it with branch equal to, I will check if the branch is equal to s0, that is s0 is what, my button. So this is little more complicated, so try to follow what I have told. So first it would check is what, s0 is my button, so it will check if branch is equal to s0 and that temporary t0, then that is I will go to case 1, because t0 right now I have put 1. Now I will change again the t0's value to be 2. Then I will check again branch is equal to s0 t0. So now my t0 contains 2, means I'm going to go over case 2. Understood? Like that. Like that is how we are going to do. And every time you have to keep j end, because otherwise other steps would be getting executed. So we don't want that. So we have to go to j end. Understood? Okay, so now it becomes very lengthy. Now while loop and for loop we will do in the next class. Thank you. So if you have any doubt, please tell it in the comment section. Thank you.